Hello, everyone. Wouldn't it be nice if we could shift left on cloud testing and shorten the development loop from hours to seconds without having to wait all the way to the end of the pipeline? During this section, we're going to be discussing cloud testing without the wait and how to transform the Kubernetes developers' experience. A little bit about me before we dive in. I am Anita Ihuman. I'm a developer advocate at Metal Bear, where we're building a cool tool called Mirrord that aims to make developers' life a lot easier. I like to think of myself as an open source fangirl, and that is because a lot of my work revolves around open source tools and open source projects. I am a member of the Chaos Board, where we focus on improving open source community health and analytics. And when I'm not doing open source work or advocating for development tools, you'll find me organizing local community meetups at KCD Nigeria and CNCF Abuja. Now that we have that out of the way, let's look in. During this section, we're going to be looking at first the traditional development workflow. Then we'll move on to talk more on what shifting left on cloud testing is all about. And obviously, we're going to talk about the benefits of shifting left on cloud testing. And if the gods of demos allow us, we'll look briefly at a demo of how Meridi works in action. So let's get in. First off, let's think about the traditional development workflow for a second. As developers, ideally, you'd want to just write your code base, right? And then once it looks good, you create a pull request, it runs through the automated test, and the process just goes on smoothly. You quickly iterate whenever a fix comes up, and then you deploy it, right? However, that's not often the case because with cloud based applications now, instead of just writing our code base and then making sure that it goes through the pipeline without any hassle, we find ourselves like wrestling with adjacent issues where you write the code base, but then you also need to build the code base and then ensure that your code functions correctly in the containers. And then you also have to like make sure that this code runs in the clusters and then it plays nicely with like other containerized apps. And then it's finally tested and then deployed to production without breaking anything. Now we see that cloud testing enters the picture like at the far end of the pipeline, right? And you might think that is not so much of a big deal. However, the issue with this particular workflow is that since we're dealing with cloud based applications, which are often complex in nature, we're having up to hundreds and thousands of like microservices. And these microservices require like a lot of like resources that developers are not subjected to dealing with difficulty debugging these applications. And in the case where like testing, especially against like production states, is at the far end, whenever those issues that reproduce themselves in the cloud or in production are not noticed at the initial phase, the developers will assume there are actually no complications and the application will go through all of these phases without having to deal with that. And you find it at the end of the pipeline, then only to realize that there's an error somewhere or there's something that is broken in the production state that needs to come back. And then you need to go through this entire workflow that we just looked at. And that can really be very difficult to fix on its end because it could take hours and 2 days from the developer's time, depending on how complex these applications are. And I know that so many persons are probably saying that we have mocks on, our team has mocks that we often use, so that's not a big problem. However, the issues with these mocks are that they only give you like suboptimal conditions that you're testing against. And because these mocks give you like an implicit assumption of what the production state would look like. And you still have to deal with like configuring and like managing the smokes. So first off, you're not getting the 100% assurance that your application would function this way in production. But then you also have to manage the workload of configuring and then maintaining these particular mocks. And all of that is on the developers, which adds like additional complexities to the developers. And then let's not talk about like how this plays a huge role in like the productivity of the developers at the end of the day, because now they have to deal with the endless build, push, test cycle, which affect like the overall development loops and affects their performance and productivity on the long run. And obviously we can't leave out the fact that this also like um adds to like increase in cloud costs because so many organizations today have opted for like remote development environments where each developer is assigned their environments that they have to work with. As if maybe you're working with a team where you have like hundreds of developers, each individual developers has like their own assigned environments that they're making their changes and doing all of these changes in. And that alone takes up a whole lot in terms of paying for these cloud resources that you're actually subscribing to. And you also have to think about the fact that by the time all of this is done, the application is taking longer to get to the market since there's a lot of like rework that is going on in the process back and forth. The application takes a longer time to actually hit production like than you would anticipate it to. No wonder a research by the National Institution of Standards and Technology states that the longer it takes for testing and also identifying and then resolving issues, the more impact it actually has on the cost and also security of the application. And what this actually tells us is that it's a lot easier to detect issues, right? When the developers are still writing the code base or when the developers still have much control over the code base compared to when the code base is like at the far end of the pipeline. And so it's easier for them to identify the issues if you have access to that production based environment. It's easier for them to tackle these issues without having to go through all of this chaos that they could deal with if it's tackled at the initial state. And then once the software is like in the testing phase, reproducing certain issues in the local environment tends to produce additional complexity because now you have to like think of how to reproduce that particular state in the local environment. And so many developers now have to like, if maybe the application or the team is working with like local based development environments, the applications might not actually, their softwares may not be able to handle all of the data, the environmental variables, and the resources that the application in production would need, which also adds like another level of complexity to the whole process. Additionally, why it's easy to catch certain issues or certain bugs during like development, right? Because your application or you're not testing against actual production state, it's still difficult to identify these issues. And like I said earlier, the mocks that a lot of organizations are using today cannot actually mimic the databases, overall database, environmental variables, and also resources that this application would need 100% in production, still leading us to so many questions at the end of the day. Now, this leads to why we actually need the shift left on cloud testing. First of all, the concept of shift left testing on its own is like the stage of the process where you like push testing to the left or you push testing overall to the early stage of the pipeline. And the idea of this approach is to actually identify and also resolve bugs and in the early stage of the development process before it gets all the way to the close to production. However, in terms of cloud-based application, we're talking about, or in terms of this particular topic or presentation, we're focusing on shifting cloud testing left. And what this means is moving cloud-based testing to the early stage of development, allowing developers to validate their code in real cloud against real cloud environment without waiting all the way to for the staging or for the deployment at the end of the day. And the goal is to actually improve software quality and also reduce the time that developers spend in resolving issues. And over time, improve the entire software development workflow for and also like developers' experience on the long run. And the key principles behind this is first, you want to be able to identify issues very early into the development. You want to be able to catch the bugs at the initial phase, like before waiting to the end, which saves a lot of time for the developers. You also want to ensure continuous feedback loop because instead of having to go over and over the development loop, which like slows all the time of reiteration, you want to regularly get feedback as fast as possible so that you can move on to the next phase of the development workflow. You also want to produce high quality applications that have fewer code when it gets to testing. And you also want to be able to reduce the instances of like delay in application delivery instead of spending hours writing and rewriting and fixing the code over and over again. You want to just test it in the local state where the developers are more familiar with the tools and get the issues out of the way as fast as possible, and then push finally to for deployment and so on. And so the benefits of actually shifting cloud testing left are, obviously, it comes with so many advantages. We've looked at some of the challenges of this, and the benefits of this, not only to the developers, but to the organization as a whole, is that you're able to detect the bugs at an early stage, which makes it very easier to like identify the issues where need be, not just issues that would appear in the local state, but the issues that would appear in the production state. Identify them as early as possible in the stage of development when developers are still writing the code. You want to be able to increase the efficiency of course, early bug detection in the environments that, especially when they are like closely the environment that closely matches like the production, leads to a smoother development workflow. Another benefit is that you want to save a lot of costs because instead of paying so much for cloud resources for like your number of developers and all of that, you could actually work with a shared development environment where every single developer has access to this without paying for like individual cloud costs. And you also want to like fasten the development because you want to quickly iterate within these tight feedback loops without waiting for the build, push, test circle that developers would normally deal with in traditional development workflows. And you're also thinking about the developers' well-being on the long run, because this gives developers the confidence that they can actually write code and then run like their testing more frequently without having to go through so much chaos and all of the hassle that the traditional development workflows introduce, which is why a development tool MirrorD becomes very much of a high need. And if you're wondering what MirrorD actually is, it's simple. MirrorD is a development tool that connects like your local processes to a remote cluster. So you can actually test and debug as if you're running your code in production without actually deploying it first. Now, with MirrorD, developers can actually work locally, but on a remote shared development environment. And every developer has like access to the cluster services as if they're running it locally. They can actually reroute the cluster's traffic, local services, and all of this while keeping convenience like the local development environment that they're very much familiar with, as well as debugging tools that they're also like very familiar with. So it becomes a lot easier to test your code on a cloud environment that, let's say staging, for instance, without actually having to go through the hassle of Dockerization, continuous integration, and deployment, without also disrupting like the environment by deploying untested code. And the good thing is MirrorD comes like with your IDEs that you're very familiar with, VS Code or IntelliJ, and it's also available in like in the CLI with just a simple command. You have MirrorD running in a matter of seconds. And to break it down, when you're running like a development workflow with MirrorD, instead of going back and forth like we looked at earlier, you write your code base and confirm that it actually works well, not just works well locally, but then because you actually tested it against cloud-based conditions at the initial or like at the development phase, you can go on and create a pull request. And obviously, because this has been tested and you've made sure and confirmed that the application is working well and it would work well, even if it goes through all of the pipeline, you open your pull request and then every other test that is expected passes through without any struggles, and the application is finally deployed to staging, and the end-to-end testing also goes on smoothly, and finally you can deploy your application to production without any challenges. So what happens when you run MirrorD is that MirrorD runs in two places: in the memory of your local process, which is the MirrorD layer, and as a pod in your cloud environment, which is the Mirror-D agent. So when you initiate Mirror-D or run it in like your IDE or in the CLI, Mirror-D, it starts like the pod called the Mirror-D agent, which operates like within the same network namespace as the pod that you're targeting, or the specific remote distant pod that you're targeting. And then this agent tends to have access to everything that your application would need in the cloud state, like the networks, the file systems, the environmental variables, and all of that. And so your local machine doesn't have to do like all of the heavy lifting and the managing all of this like it would in the traditional workflows that we looked at. Whereas on your system, the Mirror-D layer is going to integrate with like your local development environments, intercepting and redirecting all low level functions to the Mirror-D agent. And what this does is allows you to interact with the resources like the files, databases, APIs, just like your application would if it was actually running in the cloud basis. And the end result of this is that the remote server relayed back to the developer machine. And so instead of having to do all of the heavy weight lifting of managing this locally, you're able to assess the state of the application like it would in real time on your local machine, while Mirror-D does all of the heavy lifting. And this happens in a matter of seconds without even realizing it. And at the end of the day, your developers feel like they're actually running their applications as if it is in the cloud. Enough of the rambling. Let us actually look at how Mirror-D does all of this magic in the background. Okay, so for this demo, I have a very small microservice application or project that I would like us to look into. Assuming I'm working in a team that has multiple microservices and I was assigned this project, a weather app to the weather app microservice, right, to debug, and maybe this header was no longer suiting and I need to update that. And by the way, this weather app project basically just calls to an API and it returns the weather update in different cities, like you can see here. And so assuming I want to like change that and I don't like the color of this background because it doesn't suit with maybe the brand anymore. And I don't like the text on the header because it doesn't also align anymore, and I want to make changes to this, right? I'm going to first of all go to the code base. By the way, this application is running on AKS cluster, right? And so what I'm going to do is let's update this here. KCD Accra demo project. And assuming I also want to change that color, I'd change it to maybe purple. They give me like a purple background at the end of the day. And if you're wondering how to actually get started with Mirror-D, in case I didn't point that out, Mirror-D runs like a CLI, but it also has an extension. And this extension is available on VS Code right here, and also like on IntelliJ. So depending on the one you actually want to go with, the speed and everything is, but I'm going to just use the extension to show you how simple it can be. I already have my extension installed, but once you install the extension, you get like an icon at the bottom here that says Mirror-D. It's disabled right now, but if I want to use Mirror-D, I have to enable it by toggling on the button. And then you can select like an active configuration. What happens to the configuration file is it's just a way for you to customize what you want Mirror-D to do, where you want Mirror-D to have access in. Like for instance, I am targeting the weather app deployment pod, but you can choose the particular service that you want to target, right? Or the particular pod you're targeting. And then you can define what you want Mirror-D to do. By default, Mirror-D kind of mirrors the traffic and mirrors the state of the cluster, but you can actually tell it to steal incoming traffic and outgoing traffic instead of mirroring it. And then it's also like able to get me environments, the return all of the file systems and so many other things. But basically, this is a basic Mirror-D configuration file. There's so much more you can do with these Mirror-D configuration files. So now that I have my configuration sets, the Mirror-D is enabled, and the changes I also want to do have also been implemented. I'll look at my api.py file. This looks good. Next thing, I'm going to go to the debug and hit start debug. And once you do that, Miradi is going to take a matter of like seconds to initiate. It's going to like get the binaries that you need and every other thing set up in a matter of minutes. And just like I said, Miradi has already started getting itself ready to do its job. You can see that it's already started. The debugging process is active. And yes, once you see that it's turned orange at the bottom here, it's a sign that Miradi is like already doing its job. And like I mentioned earlier, what happens when you like start Miradi is it injects like the Miradi agent into the pod that you're targeting, right? Let's go and see if the Miradi agent exists right now. Okay, so we have the Miradi agents right here that is already running. It started 56 seconds ago. And that shows us that if we want to check the changes to this particular project, it's going to be implemented. Now, this is what the application in production looks like. Now, let's try to run this same thing. The good thing is you can actually use the same URL for the project and it will still render the same returns. So now we have the version that actually says KCD Accra demo project. And if you try to also check the weather, it should come out in purple, which is the color we indicated, right? So now that is exactly what you're going to get with, regardless of how complex the project it is you're working on, this is how fast Miradi works. And the good thing is Miradi does not select maybe technologies or languages to work on. Any technology that you're using for your project, Miradi is going to work regardless, and it is just as fast as possible. And basically, that is how Miradi works. And another amazing thing with Miradi is, right, once you're done with this, once you're like done with this whole process, you can actually just see that the Miradi agent will automatically terminate itself once you're completed with the debugging and you disable Miradi. It will automatically disable itself and leave the cluster without any interruptions or doing any further damage to the cluster at all. Let's see how that goes. While this is even going on, the application in production, nothing is affecting it. And let me show you what I mean. While this works, the application itself in production is not affected. And then, so I'm going to, first of all, end this debugging session and then disable mirror D. And if you try to reload this, it's going to go back to the original state of the application as it is in production, right? Now that works fine. Now let's see if the pod still, the Miradi agent still exists. Now the Miradi agent no longer exists here because we have already ended the whole debugging session and it is completely terminated, right? Now, one exciting thing, or Miradi has a lot of exciting things, by the way. But like one exciting thing about Miradi is that you don't actually need root access to use Miradi. It is easy to get started with. You already saw how you can install Miradi, and in a matter of seconds, you're already working with the whole project, right? And Miradi is not invasive to like your remote cluster. So it just attaches itself to the specific board. And once you're done with the whole debugging session, it's destroyed immediately. In a matter of 15 to 30 seconds, Miradi is already started up. So you're not wasting lots of time loading things or downloading anything. You're here just going to like your IDE to install it is all that you need to get started with Miradi. And you can run multiple processes at once, right? Each connected to like different remote pod. And you're not even limited to just maybe one specific pod at a time. You can get all of that with Miradi. And it also does not care how your cluster is set up at the end of the day. So whether you have like a service mesh or you're using a VPN or any other thing, Miradi will still work regardless. And like I said, we have a configuration that you can also customize things to your project's need at the end of the day. And so if you have any questions or you want to basically learn more about Miradi, we have a QR code here that I would say you should scan. This will take you like to the Miradi website so you can find out more about Miradi. But then you can also like just type miradi.dev and it will take you to the website. If you want to check out the repository, Miradi is open source, so you should feel free to start a project and appreciate the developers for doing such an awesome project. You can start Mirror D. If you want to contribute to Mirror D as an open source enthusiast as well, Discord community is really welcoming. We're able to support you in any ways that you can to make your contribution experience really smooth. So you can also check out the Discord and then say hi. Once you do, just say hi. You're joining from KCD Accra, and I will indicate that you're welcome and give you any resources that you need to get started. If you also just want to find out more about Mirror D and chat about how you can use it in your development workflow as well, feel free to reach out to me via my email or any of like my social media platforms at Anita Ihuman. Thank you very much.